Hello children, welcome to VKM Academy. This is VKM. In this video lecture, we will be talking about another topic from organic chemistry of class 11 or first year, that is aromaticity. It is very important topic children for JEE point of view. So I'll be making video on aromaticity to identify which compound is aromatic, which compound is non-aromatic, which compound is anti-aromatic. Any compound to behave as an aromatic compound, it must obey certain conditions. What are the conditions it should obey? First thing, that compound must be cyclic. Remember that an open chain compound will never be aromatic. A closed chain compound may act as an aromatic compound, and it should be planar. It should be planar. It is another condition can be taken, and each member of the ring should be sp2 hybridized. Each member of the ring should be sp2 hybridized. Then only it can behave as an aromatic compound. Another important condition, it should have closed conjugation. It should have closed conjugation. Conjugation must be present throughout the ring or throughout the cyclic system. Such kind of conjugation is nothing but closed conjugation. A conjugation may be pi conjugation, pi positive charge conjugation, pi negative charge conjugation, even lone pair also can be taken. Such type of conjugation must be there throughout the cyclic system or throughout the ring itself. Another very important condition, it must obey Huckel's rule. It must obey Huckel's rule, also to be taken it as 4n plus 2 pi rule. In that, n should be 0, 1, 2, 3 and so on. If we get n, any of these values, it can be considered as an aromatic compound. If it obey all of these conditions, a compound can behave as an aromatic compound. Hope that is clear. Let us try to understand this aromaticity with the help of more examples. Any of the molecule, if it satisfies these conditions, it can be considered as an aromatic compound. One of the parent aromatic hydrocarbon, which is well known and popular aromatic hydrocarbon, that is benzene. Benzene, 4n plus 2 pi electrons, we have to check it. 4n plus 2 pi electrons is equal to 6 pi electrons, because 3 pi bonds are there. Each pi bond is 2 pi electrons. 3 pi bonds means 6 pi electrons. So 4n pi electron plus 2 pi electron is equal to 6 pi electron. This is the way I am giving how to find it out the n value. The same thing you must apply it for remaining examples. Then 4n pi electron is equal to 4 pi electron. Then n value can be taken it as 1. So n must be either 0, 1, 2 and 3 and so on. But we got n is equal to 1. And moreover, each member of the benzene ring is sp2 hybridized. It is having closed conjugation. You can check it over there. Pi conjugation, and this pi have conjugation, and this pi have a conjugation. Conjugation is present throughout the system, and this compound I can consider it as aromatic compound. Aromatic compound. Another compound can be taken which is also considered to be aromatic compound. This is naphthalene. In naphthalene, if you notice it, all conditions are satisfying. Let's check it with Huckel's rule also. Total number of pi electrons, that is 4n plus 2 pi electrons, is equal to 10 pi electrons. Because there are 5 pi bonds, and hence it can be taken as 10 pi electrons, and 4n pi electron plus 2 pi electron is equal to 10 pi electron. Then 4n pi electron is equal to 8 pi electron. So n can be taken it as 2. If n is equal to 2, it is satisfying the condition. Then n is equal to 2 means it can be taken it as aromatic. It can be considered as an aromatic compound. In the similar way, you can consider even another example, that is anthracene. You can check it. It is having closed conjugation. Compound is cyclic. It's a ring, of course. Conjugation is present throughout the system and all conditions are satisfying. So it obeys the Huckel's rule also. Like 4n plus 2 pi electrons is equal to total number of pi bonds is 7. Then 14 pi electrons are present. Then n value will be 3. If n value is 3, in the sense this compound is taken as aromatic compound. Like that, any compound, if it satisfies the above conditions which I mentioned it, and if it obeys Huckel's rule, those compounds are considered as aromatic compounds. These are preliminary compounds, can be considered as examples, like this is benzene, this is naphthalene, and third compound, that is anthracene. Now we will be considering various examples, whether those are aromatic or not, we will check it up. Next example I am taking, this is cyclopropanyl cation. This is called as cyclopropanyl cation. Cyclopropanyl cation, it is having pi positive charge conjugation, and this conjugation is present throughout the ring, and there are 2 pi electrons. Then 2 pi electrons, in the sense 4n plus 2 pi electrons is equal to 2 pi electrons. Then n value can be taken it as 0. If n value is 0 means it is aromatic. But if you write the resonance hybrid of this, in this positive charge is delocalizing. Throughout the ring, positive charge is getting delocalized, and hence I have represented resonance hybrid with positive charge. It indicates throughout the ring positive charge is delocalized. It is cyclopropanyl cation. In a similar way, I can take cyclobutynyl, right? Cyclobutynyl dication. This is called cyclobutynyl dication. 2 pi electrons are there. Pi is in conjugation with this positive charge, as well as this pi is in conjugation with this positive charge. And then positive charges are getting delocalized. So number of pi electrons are 2 pi electrons. If 2 pi electrons are there means n is equal to 0, and the compound is taken it as aromatic compound. And rest of all the conditions are satisfying. And moreover, if you write the resonance hybrid in this, there is a charge delocalization, but which charge is getting delocalized? 2 positive charges are getting delocalized throughout the ring, and hence I have represented resonance hybrid in which 2 positive charges are getting delocalized. And now another example can be taken. Hope you are copying these examples. You can just pause it and then you can copy the examples also. And another one can be taken. This is cyclobutynyl dianion. A negative charge is considered as one lone pair, right? A positive charge cannot be accounted for the pi bond, but whereas negative charge can be accounted for the pi electrons count. So here 1 pi bond, 2 pi electrons, here electrons, and here also pair of electrons. So total number of electrons must be taken it as 4n plus 2 pi electrons is equal to 6 pi electrons. 4n pi electrons must be equal to 6 pi electrons can be taken. And then n value is 1 and the compound is aromatic. Compound is taken it as aromatic. If compound is aromatic in the sense resonance hybrid, in this two negative charges are getting delocalized throughout the ring. So if two negative charges are delocalizing, such a way we can represent it. And next compound we are considering it. The next compound is there is a negative charge over here. It is called cyclopentadienyl anion. Cyclopentadienyl anion, 2 pi bonds and 1 negative charge. That indicates total number of pi electrons are 6 pi electrons. If 6 pi electrons are there, n is equal to 1 and it is aromatic compound. It is aromatic compound. There is a conjugation pi negative charge pi pi conjugation with these 2 pi bonds. Conjugation is throughout the system, throughout the cyclic system, and hence it is said to be closed conjugation. So cyclopentadiene, negative charge is delocalizing throughout the ring. Negative charge is delocalizing throughout the ring. So if negative charge is getting delocalized, that is the resonance hybrid, we are going to get it for cyclopentadienyl anion. It is an important compound to be considered for aromatic. Okay. So cyclobutynyl dianion, cyclopentadienyl anion, another two examples for the aromaticity. Let us talk about few more examples. Most popular example it is 7-membered ring. Okay. It is plus cycloheptatrienyl cation. Cyclohepta because 7-membered. Trienyl in the sense 3 double bonds are there. There is a cation over there. The cycloheptatrienyl cation, commonly known as tropylium cation. Commonly known as tropylium cation. There are 6 pi electrons, and you can see there is a throughout the ring closed conjugation. 6 pi electrons means n is equal to 1. N is equal to 1 means compound is considered as aromatic compound. Moreover, tropylium cation, it is an example of a carbocation. It is one of the most stable carbocation because of aromaticity. In organic chemistry, among so many stabilizing factor, aromaticity is also one of the stabilizing factor, of course, which is the dominant stabilizing factor compared to other stabilizing factors can be seen. Now there are 7 carbons in this compound. You can see that is 7 carbons. In that all pi bonds are in conjugation, and these pi bonds are in conjugation as well as these pi bonds are in conjugation with positive charge, and hence cycloheptatrienyl cation is an example of aromatic compound. Now in the similar way, I can take cycloheptatriene. If you notice cycloheptatriene, there are 6 pi electrons. That doesn't mean n value is going to be equal to 1, and that doesn't mean it is going to act as aromatic because it is not having closed conjugation. Here pi, these 2 pi bonds are separated by 2 sigma bonds. Conjugation means 2 pi bonds are separated by 1 single bond or 1 sigma bond. But here 2 sigma bonds are present. It cannot act as aromatic compound, and this compound is non-aromatic compound. This compound can behave as a non-aromatic compound. So cycloheptatriene is not an example of aromatic compound. In the similar way, you can see some heterocyclic compounds. You can see some heterocyclic compounds. Heterocyclic compounds are those compounds in which along with carbon and hydrogen, one heteroatom must be present. Such type of compounds are said to be heterocyclic compounds. Let us try to understand with the help of few examples. It is called pyrrole. However you pronounce it, it might be called as pyrrole or pyrrole, right? Here itself, this lone pair must be involved in conjugation. If lone pair is not involved in conjugation, it cannot behave as aromatic compound. So lone pair as well as these 2 pi bonds, total number of pi electrons are 6 pi electrons and n is equal to 1. But this lone pair on nitrogen, I can take it as lone pair is delocalized. Lone pair is delocalized. Then only that compound pyrrole behave as aromatic compound. N is equal to 1 means this compound is aromatic compound. Okay, that means lone pair is delocalized. Lone pair is delocalized in the sense 3 sigma bonds are there. Whenever lone pair is delocalized, it cannot be accounted for hybridization. You have to consider only these 3 sigma bonds. 3 sigma bonds hybridization can be given it as sp2. Such a way can be taken. In the similar way, you can consider one more example, which is a well-known example. You might have heard about it. This is called pyridine. Pyridine C5H5N, another important example of heterocyclic compound. If you notice it over here, there are 3 pi bonds. 3 pi bonds is equal to 6 pi electrons. These 6 pi electrons are there in conjugation. Then there is no point of involving this lone pair in conjugation. Now this lone pair can remain on the nitrogen only. This lone pair is not involved in conjugation. If it is not involved in conjugation also, pyridine can behave as aromatic compound because 6 pi electrons means n is equal to 1. N is equal to 1 means the compound is taken as aromatic compound. And lone pair, this lone pair on nitrogen is localized. Lone pair on nitrogen can be taken it as localized. It remains on the nitrogen only. It is not participating in the ring. It is not participating in the conjugation with the ring. Okay, and hence it is said to be lone pair is localized. But whereas in case of pyrrole or pyrrole, lone pair is delocalized. So if lone pair is localized, in such cases you must count that lone pair for the hybridization. That means okay, 1 sigma bond here and 1 sigma bond here and 1 lone pair. 2 sigma, 1 lone pair. That indicates hybridization is sp2. These are nitrogen containing heterocyclic compounds. In the similar way, you can consider oxygen containing heterocyclic compound also. Oxygen containing heterocyclic compound. This is oxygen containing heterocyclic compound and this compound name is furan. And here one lone pair is delocalized. If that lone pair is involved in delocalization, then only it can behave as aromatic. But whereas another lone pair is localized, it is not involving in conjugation. If it is not involving in conjugation, then it is said to be lone pair is localized. So total number of pi electrons are 6 pi electrons. 6 pi electrons means n value is 1. N value 1 means okay, it is aromatic because it is obeying Huckel's rule. Okay, so it is said to be furan. In a similar way, I am going to take one more example of heterocyclic compound in which sulfur is the heteroatom. This is thiophene. In the same way of furan, where oxygen is having 2 lone pair of electrons, no? Whenever oxygen is having 2 lone pair of electrons, in the sense one oxygen lone pair is delocalized, another oxygen lone pair is localized. In the same way here, this lone pair is delocalized, another lone pair is localized. One lone pair is delocalized in the sense it is involving in conjugation. So this lone pair is delocalized, whereas another lone pair is localized. Another lone pair is localized. So here also for thiophene 6 pi electrons, 6 pi electrons means n is equal to 1. N is equal to 1 means compound is aromatic. Compound is aromatic. Such a way we can decide whether the compound is aromatic or not. In this way, whether it is satisfying Haeckel's rule or not, we can check it. Now so far we have discussed about heterocyclic compounds. Now let us talk about polycyclic compounds. Polycyclic compounds, if you notice it, polycyclic compounds, again these are classified into two types. These are classified into two types, children. One is fused polycyclic compounds and another one is isolated polycyclic compounds. Fused polycyclic compounds, I have already given examples. Two benzene rings are fused. This is naphthalene. If three benzene rings are fused, that is said to be anthracene. First one is naphthalene and another one is anthracene. Fused means one ring must be combining with another ring. That is said to be fused. Here two rings are fused. Naphthalene. Three rings are fused. Anthracene. We have already seen examples. Both of these are examples of aromatic. When it comes to isolated polycyclic, poly means many. Many cyclic systems or many ring systems or many closed systems must be present. Isolated in the sense separate benzene rings should be there. Like this. Two benzene rings are there, right? If three are there, that is also isolated polycyclic. If two are there, it is said to be biphenyl. In this case, if you notice it, each and every benzene ring must be taken, right, for aromaticity. Here this benzene ring is having 6 pi electrons. If 6 pi electrons are there, n is equal to 1. N is equal to 1 means compound is aromatic. In a similar way here also 6 pi electrons, then n is equal to 1. It is also behaving as aromatic. To behave as aromatic, you must consider each and every ring individually. Individually you should take into consideration this is aromatic, then the whole compound called biphenyl is an example of aromatic compound. Such a way aromaticity can be decided for various compounds like fused polycyclic compounds, isolated polycyclic compounds, heterocyclic compounds also. Remaining compounds, okay, list will be given in the next part of the aromaticity, and in the next part we will be talking about even anti-aromaticity as well as non-aromaticity also. Hope you like the video. For more and more videos, please like this video and as well as subscribe to my channel VKM Academy. Thanks for watching, children. We will meet in the next video.